Hello students, welcome to the channel TopGATE. Today we are going to discuss one more problem of Turing machine, that is to design a Turing machine for the language L is equal to 0 to the power n, 1 to the power m, 0 to the power n, 1 to the power m, where the value of m and n is greater than equal to 0. Now if you analyze this, in this one there is no dependency between n and m, okay, that is the number of zeros can be different from the number of ones, and we have to make sure that this part of the string is equal to this part of the string and this part of the string is equal to this part of the string. Okay, so that is our main concern. We have to compare all these things. Fine. Now since the value of m and n are independent of each other, so in this we can have several cases. So the first case can be if the value of m is greater than 0 and the value of n is also greater than 0. There is a straightforward case, a simple one, a very first case. So in this one, if I take the value of m and n is equal to 2, okay, so I'll take the value of m and n is equal to 2 only every time. So the string in this case will be 00110011. Why? If we put the value of n is equal to 2, m is equal to 2, then we'll get 00110011. That is the first case. That is a very straightforward, a simple case. Okay. Second case is if the value of n is greater than 0 and the value of m is equal to 0. Okay. So in that case there will be no ones, there will be only zeros. Fine. If I take the value of n is equal to 2, then I'll get 0000, that is 00 and 00. Fine. Now third case is if the value of n is equal to 0 and the value of m is greater than 0. Now in this case this 0 will not be there. So in the string we'll be having only ones, that is 1111. And the last case is if the value of n and m both are 0, then in that case I will get epsilon, that is the null string. Okay. So we have to design a Turing machine that can satisfy all these four cases. Okay, so I'll start with this one, the very first case. So I'll make a Turing machine for the first case and then try to incorporate all these three cases into the first one. Okay, now if you see the this case number 2 and 3, in case number 2 it is saying the string will always be an even length string. Okay, now why am I concerned with even length? I'll tell you why. Why even length? First of all, even length is because suppose I have this 0 strings. Okay, so in this 0, if the value of n is equal to 1, that is a odd number, so 1 plus 1 will be 2, that is an even number. If the value of n is equal to 2, that is an even number, so 2 plus 2 is 4, so that is also a even number. So in any case I'll get a even length string in this case. Okay, and similarly the third case, if the value of n is 0, that is this 0 is not there, only ones are there. If I take the value of m is equal to 1, then also it is even. If I take the value of m is equal to 2, then also it is even. So in any case it will be a even length string. Okay, now why am I concerned with even length? Because I have to make sure that the first part of the string is equal to the second part of the string. Okay, but I don't know where is the center in that string. So in this string, manually if I can see, so I can see that this is the center of the string, but our system cannot see that this is the center of the string. So we have to just, because we don't have to compare in this one. Why? Because we know that all the characters will be 0 in this case, so we don't have to compare this first part with the second part. So what I'll do, I'll simply find out that whether the length of the string consisting of zeros is even or not. If it is even, then we can go on to the final state. If the length of these zeros is odd, we will not go to the final state. Similarly in this case also, if the length of these ones is even number, then only we can go on to the final state. So let's start doing this one. So I'll start with the case 1 and then try to incorporate these three cases into the first one. So the first case is m greater than 0, n greater than 0. In that case the string that I have is 00110011. I can take any value here, so I can have any string here. That is, if I take the value of m and n is equal to 3, it will be 000, 111, 000, 111. So I'll take this one only. Okay, so let's take the input tape first. And the input tape, the string that I have is 00110011 and then followed by blanks. and the read write head is currently onto the first 0. Okay, so let's start doing this one. So I'll start with some initial state, say Q0. Okay, so at Q0 what I'm finding, initially I'm finding a 0. So what the logic is? The logic is I'll start with this one, with this 0, and I will read this 0, and after reading it I will rename it to say X. Okay, so this will be X. Then I'll go forward onto the right direction. I'll skip this 0, I'll skip these ones, and this first 0 I'll again make it to say this time Y. So this, the first one I have made as X, and now I'm going on to the right direction to find the pair for X. Okay, so pair for X will be a Y in this case. Fine. So I got this 0 first, then I went forward, and onto the right side I am finding the pair for this 0. As soon as I found the pair for this 0, I'll make it as Y. Again I'll come back here, again I'll find this 0 and I'll make it as X. Again I'll go forward, again search for the pair for this one. So every time I'm searching for the pairs of these characters. Okay, so first I'll do for 0, then I'll do for ones. Okay, so this will be compared with this one, this will be compared with this one. Okay, so let's start doing this one. So we have the initial state as Q0 and the element to process is 0. Okay, fine. So if you come across 0, you should change it to X and go to the right side. So this 0 will be changed to X and the pointer will point on to the right hand side, that is a 0, and the machine will reach on state Q1. Okay, now at Q1 what I'm finding zeros, so I should skip these zeros. That is, if you find 0, keep it as 0 and go to the right side. So all these zeros will be skipped and the pointer will now point on to this one. Okay, now again I need to skip this one. Why? Because I need a 0 only. Onto the right hand side I'll find one 0, so I'll go onto the right hand side to search for a 0. So this one has to be skipped. So what I'll do, if I find 1, I should keep it as 1 and go to the right side. So this one will be skipped and the pointer will point on to the next one, and the machine will go on to state Q2 now. Okay, now at Q2 again I'm finding a 1. So here also I'll take a self loop, that is, if you find 1, keep it as 1, go to the right side. So this one will also be skipped, and finally my pointer is on to the first 0, and this 0 I have found a pair for the previous 0. Okay, so what I'll do, if you find 0, you should change it to Y and go to the left side, and don't go on to the right side, because right side my work is done. So I'll again come back to the initial state and start my second iteration. Okay, so I'll reach on state Q3, this 0 has been changed to Y and the pointer is pointing on to this 1. Now again I need to skip everything. I need to come back to X, and to the right of X I'll find my next element. Okay, so here what I'll do, I'll take a self loop, that is, if you find 1, you should keep it as 1 and go to the left, and you're finding a 0 also. If you find a 0, you should keep it as 0 and go to the left. So all these 1s and all these 0s will be skipped, and the pointer will now come on to this X now. Okay, now I need to come back to the initial state. So here I'll come to the initial state, that is, if you find X, you should keep it as X and go to the right side. So this X will be X only, and the pointer will point the next 0 now. Okay, and the machine is at Q0 right now. Now at Q0, machine knows that 0 has to be changed to X. So it will change this 0 to X and the pointer will point on to the next one. And at Q1, machine knows that if you find 1, you should skip this one. So this one will be skipped and the pointer will point this one. Again at Q2, machine knows the 1 has to be skipped, so it will again skip this one and the pointer will now point on to this Y now, and the machine is at Q2. Now at Q2 I don't have a move for Y, I have a move only for 0. So what I'll do, I will take a move for Y. If you find Y, you should keep it as Y and go to the right side. So this Y will be skipped and the pointer will now point on to the next 0, and the machine is at Q2. Now machine again knows at Q2, if you find 0, you should change it to Y and take a left turn. So this 0 will be changed to Y and the pointer will take a left turn. It will come on to this Y again. Okay, now again I need to come back to X to the right of which I'll find my next element. Okay, so I again have to start the third iteration. Fine. So what I'll do here, I need to skip this y. So if you find y, keep it as y, go to the left side. So this y will be skipped, this 1 will be skipped. So all these 1s and all these y's will be skipped, and the pointer will now point on to this x, and as soon as the machine sees that x is there, it will take this move and come on to state q0, and the pointer will go on to the right side, that is on to this one now. Okay, so at q0 we have done the work for the zeros. Fine. Now I have to start the work for ones because we are getting a 1 this time. So what I'll do, I'll start for 1 this time. That is, if you find a 1, you should this time say, I'll change it to p and q. So this will be p's and this will be q's. Okay. So if you find a 1, you should change it to p and go to the right side. So this 1 will be changed to p and the pointer will now point on to this one, and the machine will reach on say state q4 this time. Okay, now at q4 I need to skip this 1, so I'll take a self loop here, that is, if you find 1, keep it as 1, go to the right side. So this 1 will be skipped and the pointer will now point on to this y. Okay, now I need to skip this y also. So what I'll do, I'll take a move for y, that is, if you find y, you should keep it as y and go to the right side and reach on to state q5. Okay, now at q5 this pointer will now point on to this next y. Again I have to take a loop for y, that is, if you find y, keep it as y, go to the right side. So this y will be skipped and the pointer will now point on to the next one now, and I was searching for the 1 only, so I got 1. So what I have to do, I have to again change this 1 to q. So we are searching the pair for this first one, and the first one is changed to p. So I got the pair for this one, and I'll change this 1 to q this time. Okay, that is, if you find a 1, you should change it to q and now go to the left hand side. Don't go on to the right hand side because my work onto the right hand side is done. I'll again go to the initial state to start my next iteration. Okay, and the state will be q6 this time. Okay, and this will be changed to q and the pointer will now point on to this y. Okay, so I need to skip everything now. So what I'll skip, I'll take a self loop. If you find y, keep it as y, go to the left. So this y will be skipped. Then I'm finding a 1. So if you find 1, keep it as 1, go to the left side. So this will be skipped and now the pointer is pointing on this p. Okay, now as soon as it finds this p, now to the right of which my next element will be there. So I have to again come on to the initial state. So from here I'll take a left turn and I'll go to the initial state. So I'll go to the initial state, and that is, if you find a p, you should keep it as p and go to the right side. So this p will be skipped and the pointer will now point on to this next one now. Okay, and the machine is at q0. At q0, machine again knows that 1 should be changed to p and go to the right side. So this 1 will be changed to p and the pointer will point on to this y. And at q4, this, because there is no 1, so this move will not be used. I'm finding a y, so this y will be skipped. First y will be skipped and then the second y will be skipped at q5, and finally this pointer will now point on to this q and the machine is at q5. Okay, now at q5 it is saying that we have to skip y, but I have to skip the q also this time because I'm finding a q this time. So I'll take a move for q, that is, if you find a q, you should keep it as q and go to the right side. So this q will be skipped and the pointer will now point on to this one, and the machine is at q5 only. Now at q5, machine again knows 1 should be changed to q. So this one will be changed to q and take a left turn, that is, the pointer will now point on to the previous q. Okay, now again I have to skip everything. Again I have to come to this p only, to the right of which I may find my next element. Okay, so I need to skip q this time. So I'll write, if you find q, keep it as q, go to the left side. So this q will be skipped, this y will be skipped, and the pointer will point on to this p now. Okay, now I have reached on to the P, and from this P I have to start my next iteration. So therefore I'll again come to the initial state. So if you find P, you should take this move, keep it as P and go to the right side. So pointer will now point on to this Y now, and the machine is at Q naught. Okay, now machine is at Y. Then this means that the first part of the string is complete. Okay, so we are on to the next part. So therefore this one has been completed. Now there is no more ones. Fine, and these zeros have already been changed to Y. That means that zeros have been, the first 0 has been changed to X and the next 0 have been changed to Y. So we don't have to do anything else now. We just have to go to the blank to go to my final state. Okay, so my pointer is at Y. What I need to do? I need to go on to the blank to go to my final state. So here I'll take a move for B. That is, if you find, what I'm finding, if you find a Y, you should keep it as Y, go to the right hand side. So this Y will be skipped and I'll go on to state, say Q7. Okay, I'll go on to state Q7. So this Y will be skipped and the pointer will now point on to this Y. So here I have to take a self loop. That is, if you find Y, keep it as Y, go to the right hand side. So this Y will be skipped and the pointer will now point on to this Q. So I'll take a move for Q also. That is, if you find Q, keep it as Q and go to the right side and go to state Q8. So this Q will be skipped and the pointer will now point on to next Q. Here again I'll take a self loop. That is, if you find a Q, keep it as Q, go to the right hand side. So this Q will be skipped and finally I'll reach on to the blank, and here I'll take a move for blank. That is, if you find a B, keep it as B, go to the right side and go to the final state, and we are done. So this is the first case, straightforward, a simple case. Okay, so all these zeros and all these ones have been compared and now we are done and we have reached on to the final state Q9. Okay, now take the second case. Second case is this one, that is, the value of n is more than 0, the value of m is equal to 0. Okay, now I'll take a new input tape and I'll try to incorporate this one also into this Turing machine. Okay, so the input tape that we take, I'll take it here only. Now case 2, the input is 0 0 0 0. So blank 0 0 0 0 and then blanks. And the read write here is currently on to the first 0. Okay, the first 0, machine is at Q0. Machine knows that if you find 0, you should go this way. The machine will go this way and the 0 will be changed to X. So this 0 will be changed to X and the pointer will point on to the next 0 and the machine is at Q1. Now at Q1, machine is saying that if you find a 0, you should skip all those zeros. So all these zeros will be skipped and the pointer will point this blank now. Okay, all these zeros are skipped. Now what I need to do, I just have to make sure that this is an even length string. That is, because we are only finding 0, so there is no need to compare these characters. Okay, because we are having all the zeros, so no comparison needs to be done. We just have to make sure that this is an even length string. If it is an even length string, that means the first part of the string is equal to second part of the string. It is quite obvious. Okay, so what I'll do, I have made this first 0 to X. Now again I'll go to this side, again I'll come back here and I'll change this 0 to Y. Then again X, then again Y, then again X, then again Y, then again X, then again Y. So for every X I need a Y. Okay, if I don't find a Y for X, that means the string is a odd length, so I'll not go to the final state. If I find a Y for every X, that means the length is a even, so therefore I can go on to the final state. Okay, so we are at state Q1 and it is saying that we have to skip all those zeros. All these zeros are skipped and the pointer is at B now. Okay, so I'll take a move for B from Q1 only. That is, if you find B, you should keep it as B and go to the left side. So this B will be B only and the pointer will now come on to the 0 and the state is say Q2. 10 this time. Okay, so at Q10 we are finding a 0. Again, I don't have to do anything with this one because I have to come here and right of this x I will find my next element and I'll rename that element to y. So again xy, then again xy, then again xy. Okay, so here I'll take a self loop, that is, if you find a 0, keep it as 0 and go to the left side. So this, all these zeros will be skipped and finally my pointer will point on to this x. Okay, now I don't have to do anything with this x. So what I'll do, I'll simply, if you find x, keep it as x, go to the right side. So this x will be x and the pointer will now point on to this 0. So it is now simple. We have to change this 0 to y. I'll go to state Q11 and here what I need to do, I have to make this 0 as y. So I'll take a move. If you find 0, change it to y and go to the right side. So this 0 will be changed to y and the pointer will point on to the next 0 and the machine is at Q12 this time. Okay, now again this 0 has to be changed to x. So what I'll do, I'll simply come to this one, that is, if you find a 0 now, change it to x and go to the right. So this 0 will be changed to x and the pointer will point on to the 0 and the machine is at Q11. At Q11 it again says if you find 0, change it to y. So this 0 will be changed to y and the pointer will point on to this b. So this cycle will work and this cycle will make all the zeros as x and y, x and y, x and y. Okay, so finally my pointer is now pointing on to the blank. So I'll take a move for blank, that is, if you find a blank, keep it as blank and go to the right side and go to some final state and we are done. This is case number 2. Okay, now for case number 3, case number 3 is n is equal to 0, m is more than 0. In this case I'll take 1 1 1 1. Okay, so take a different input tape this time. One 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 one. This time what I'll do, again I'll check the length of the string is even or odd. If it is even, my work is done. So I'll only check for ones and I will rename this to p and q, p and q. Okay, so what I'll do, because this is p already and q already, so we have already done that. Fine. So what I'll do now, at q0 the read write head is on to the first one. Okay, so at q0 machine knows if you find 1, change it to p and go to the right. So this 1 will be changed to p and go to the right. So the pointer will now point to the next one. Now at q4 machine is saying you have to skip everything. So all these ones will be skipped and the pointer will now point on to this b now. Okay, at q4 we don't have a move for b. So what I'll do, I'll take a move for b only, that is, if you find a b, keep it as b and go to the left side. So this pointer will now point on to the left side, that is this one. Again I have to skip this one. I'll again reach on to state, say Q14. Okay, and now I have to skip all these ones. So I'll take a self loop here, that is, if you find a 1, keep it as 1, go to the left side. So all these ones will be skipped and the pointer will come on to this p, and again I'll take a move for p, that is, if you find a p, you should keep it as p and go to the right side, because onto the right of this p I have my next element. So this pointer will now come on to the next one and the machine is at Q15 this time. Okay, and at Q15 what I'm finding a 1. So this 1 has to be changed to q this time. So I'll take a move. If you find 1, change it to q and go to the right hand side. So this 1 will be changed to q and the pointer will point on to the next one and the state is Q16 this time. Okay, now again next one has to be changed to p because we are doing it in pair wise, that is PQ, PQ, PQ and so on. So again I'll come to this one, that is, if you find a 1, change it to p, go to the right side. So this 1 will be changed to P and the pointer will point on to this one. Now again at Q15 machine knows 1 should be changed to Q. So this 1 will be changed to Q and go to the right side, that is point on the B. So this cycle will change all the 1s to P's and the Q's. And finally I am finding a blank. B should be B, go to the right side and the state is Q17, make it as final and we are done. So this is for case number 3. Now the last one, that's case number 4. Case number 4 is we have to accept a empty string also, that is blank only, that is in the string we have only blanks, that is we have several blanks and the pointer is on to the blank only. So what I'll do from here, I'll take a move for blank. If you find a blank, keep it as blank, go to the right and take a state say Q18, make it as final and we are done. Okay, so there are 4 final states. First final state is Q9, that is for case number 1. Second is Q13, that is for case number 2. Third is Q17, that is for case number 3. Fourth one is Q18, that is for case number 4. So all these 4 cases are incorporated into the single Turing machine and we are done. Okay, thank you so much.